So as you know, Professor Keith Pizzoli is trying to sort of revamp the Urban Studies and Planning senior sequence. And he plans on doing this by implementing these new online modules, or this flipped classroom environment, as I was just speaking to you about. So you guys have all probably seen this here. So without getting into the details of it, I'd just like to let you know that I'm interested in the spatial analytics and technology part, which is what I'll primarily be helping out with. So I'd just like to take you through a short PowerPoint presentation that I've made that talks a little bit about spatial analytics and spatial thinking in general, and sort of my concepts, if you will. So, thinking spatially. What does it mean to think spatially? Well, it's one thing to know where you're at, but what about your relationship to everything around you? Why are spatial relationships important in the first place? So, what about effective spatial thinking? So, in order to structure problems, you must be able to conceptualize space. To find the answers, you must be able to use the tools of representation. And in order to express the solutions, you must understand the processes of reasoning. So how can we do this? Well, we can use the geographic approach. So how can a GIS help, or Geographic Information System? Some of us think of this as a geographic information science, but we'll just focus on the idea of it being a system for right now, as I mentioned. So where can a GIS be applied? Well, it can be applied to just about anything, anything that has a space or a place. So this is a simple diagram of a GIS, which is essentially just a bunch of layers that have attribute information associated with them. Then we can have more complex geographic information systems that have different types of data and a little bit more complex. But now we can get even more complex, and this idea of geo-enablement, which would be sort of integrating computer-aided design with building information modeling and GIS and this new cloud-based technology that can store lots and lots of data that people can collaborate with through web services. So you take the GIS and you take the CAD and the BIM, and what we have is this future of planning and design, if you will, what many scholars are calling geo-design. So some concepts that I have to sort of implement these modules or tutorials or little chunks to add into Keith Pizzoli's course that we're all talking about would be teaching planning students, for starters, how to integrate software like ArcGIS, Google Earth, and Google SketchUp. So I'm not talking about teaching them how to use these programs per se. That's up to them to be able to do. What I'm talking about is teaching them how to integrate the programs together. So they have a geographic question, some sort of planning issue or a community-based issue, and they want to display some sort of geographic information about it, a map or a report model or a video like this maybe. But how do they do it? They need to know how to use the right tool. So my background is in construction, as I said, and I often like to think of using these different types of programs as I would thinking about my tools. So as a carpenter, when I go to make a cut, for example, it's important to me to know which saw I need to use to make the right cut. This is very similar to using the correct method or the correct software in order to meet whatever it is the students are trying to do. So what we're talking about is teaching planning students how to manage and transfer spatial data, but not just learning how to use the GIS and CAD. How to use the most effective method to make the spatial decisions, and understanding why they should care. Understanding workflow and developing technologies so that when they go out into the real work world or move on to graduate school, they have a more refined understanding and knowledge of what the future holds for this idea of geodesign and GIS technologies and how it can be applied to really just about anything. So what I'm talking about, for example, is taking a simple shapefile in ArcGIS and putting it in Google Earth, and then maybe putting it back in ArcGIS or not. And maybe taking a model that was built in SketchUp and putting it into Google Earth, and then moving it over to ArcGIS to do more analysis. Maybe taking a simple CAD file that somebody else has built or the student has built and moving it into ArcGIS to do some sort of analysis. The idea of taking ArcGIS, moving it into CommunityVig, which is a decision support tool or scenario planning tool. And then this new technology that ArcGIS Online has implemented, which we're hoping to start using here soon, and we could talk about more of that in the future if it gets up and running. So some other module concepts that I have is, and these are ideas that, maybe I'll do some of them, but these are for you, for you that's listening here, and this is an ever-growing list here. So there's an infinite amount of space on the internet, and we can keep creating these videos and modules that can be watched, every single quarter for years, or until they're outdated or not, and so that's the idea here, is that we can make these resources available to students and they last indefinitely, essentially. And so a professor doesn't need to keep going back every quarter to give the same lecture. They can make it once and then concentrate on more relevant things, if you will. So this is about understanding concepts and getting right to the point, teaching the student right from the get-go, and the student can go back just like you can and re-watch this video as many times as they want right before the exam. Maybe I'll put a quiz at the end of this if I want. I don't know. That's up to the professor in this flipped classroom environment. So these other module concepts that I have is theories of space versus place. So moving on, site analysis, using a contextual approach to site analysis, suitability analysis, teaching students what it is and how to do a suitability analysis, scenario planning, using decision support tools like community viz that I talked about, introducing this new idea of geodesign, the theories and giving examples, sort of the whiz-bam to get students really interested in it. Alterterra is offering us a catalog, if you will, of community-based projects where a lot of the background research has already been done in communities outside of Tijuana, and this can allow students to take these projects from just a conceptual idea or just words written on paper, essentially, to going and doing the mapping based on GPS coordinates, putting them and displaying them into a map, and then doing some 3D modeling, and then taking them to political officials or whoever, community people, to try and get funding to actually implement these programs or these developments. A stormwater mitigation bank, using vacant lot surveys that USP students have been making over the years, and doing something with it and using this for the community. And then this idea of ArcGIS Online, as I talked about. So ArcGIS Online gives students an opportunity to upload data and maps and web services and do things that the entry-level GIS user couldn't do before. It allows for spatial analysis for somebody that really doesn't know anything about GIS. You can literally just sign on, start playing with maps and producing quality maps with real analysis. So this is a new technology, and this is something that could be ongoing. Maybe we could set one up for urban studies and planning program or for particular classes, and the students upload data and projects and they keep going. So future classes can continue working on these projects and on these databases, and continue developing web services or applications to use tools to understand data that's pertinent or relevant to whatever the research it is that they're doing. So where do you fit in? So maybe you could make a video, maybe I could interview you, or someone could interview you, and you just talk about what it is that you do or you're interested in. Video lectures such as this. Just give a lecture. What do you know about? What are you an expert in? And why are students interested in that? How can it help them in the future? Video demonstrations and tutorials. So taking a software program or taking multiple software programs and literally using programs like I'm using right now, these on-screen video capturing devices, to show students how to go right through the steps, and different resources. So we can do things like, I could add a link into here and you could click on it and it could take you somewhere else. For example, I could take you to another website or to a journal or a paper, and these are just a few examples. So real-world examples. So what about these different technologies? I mean, we can talk about them all day, but the students want to see them. So let's show them, let's show real-world examples of, and get them really interested in this stuff. That's the idea here, is spark an interest in these students so that when they graduate, they have something in mind that they want to do, and they have a practical skill that they can use to understand and apply all of this great knowledge that they're learning from this research university. And then obviously opportunities for student engagement, so internships or bringing students on tours. This flipped classroom environment opens up a lot more time for students, especially the more proactive students, to be more engaged. And so this is why you're involved with this in the first place, is because we all believe that we can help each other and develop something newer and better and just a little more advanced for the future. So thank you very much for your time, and I look forward to meeting you soon if I haven't. Thanks.